Hey, 8th grade. So our learning target today is I can solve linear system by using a table, graph, and equation. So there's going to be some review work here as we start Unit 8 before we get into parallel perpendicular. So we're going to talk about linear systems, table, graph, equations. So what is a system of linear equations? A system of linear, remember the word linear means lines. We have this word here, and you can see the word line is within that. So basically they're straight line equations. It's a set of equations that have the same variables. Same variables. Okay, so we have a system of linear equations that have the same variables. So in these equations down here, you can see that the variables are x and y, two different equations. We're going to talk about solutions in this unit, which is our next lesson. So first we're going to talk about system of linear equations, and then we'll talk about some other details of it. So some review stuff. So here's our equations. X plus y equals -2, and 5y plus x equals 2. You can see that neither one of those are solved at the moment for y, but we have the skills to solve them for y and get them in the form of y equals mx plus b to make a straight line graph. So a solution is really the answer. Remember, solution is the answer to a system, to a linear system, is the values of the variable that make the equations true. So it has to be for both equations. So the answer is the xy value that is true for both equations. It can't just work for one. So that's going to be working, we'll be working for in our work today. So here we go. Is the ordered pair a solution to the system? So we have this ordered pair x comma y, always in alphabetical order. Using substitution, we're going to plug that x and the y into both equations to see if it's true. It has to work for both. So in the first set of equations, I'm going to plug a 5 in for y. I'm going to plug a 2 in for x and see if that's true. So I have in the top equation 5 equals 3 times 2 minus 1. Feel free to use your calculator if you can't do that in your head. That's really 6 minus 1. So is it true that 5 equals 6 minus 1? Yes, that's true. In the bottom equation, let's double check that that works as well. So we're going to put a 5 in for the y spot. We're going to put a 2 in for the x. In solving, we get 5 equals -2 times 2 plus 9. So we have -4 plus 9. Is it true that 5 equals -4 plus 9? Yes, that's true. Again, it has to work in both to be true. So this would be, we would say yes, this is true. Okay, so moving on to the next set of equations. Same idea. We're just asking if the ordered pair is a solution. Is it the correct answer? So as we work on to this next set, it has to work for both. Here's our x value and our y value. It has to work for both equations. We take the y of 2 and plug it in. We take the x of -3 and plug it in. The question is, does that equal -4? You can use your calculator to help you through that if you're struggling. Otherwise, we start to solve. That's 2 plus, that becomes -6. Is it true that 2 plus -6 equals -4? Yes, that's true. That is correct. In the bottom equation, then, we would plug in a 2 for y. We subtract 1 on the left-hand side. On the right-hand side, we have 2 multiplied by the x value. It says that the x value here is -3. We want to know if that's true. 2 minus 1 is equal to 1. Does that equal -6? No. So yes, it works for the top equation. No, it doesn't work for the bottom equation. So we're going to say not a solution. So this is not the correct answer for both equations. Yes, this is the correct answer for both equations. All right, so that's what a solution is. It's the correct answer. But in systems of equations, it has to work for both equations to be true. All right, working on to the next section. Now, if I'm going too fast, go ahead and pause that video. So how do we solve a system of linear equations? Well, first thing that we need to do is we need to make sure that the equations are in the form y equals. Y has to be totally alone before we can solve the system. So this one's ready to go because we have y equals. So I'm just going to transfer that over into my answer box. That one's ready. We have some work to do, however, on this one. We have not solved the bottom equation for y. Hand method kicks in. I take my hand, I cover the y. So therefore, I have to get rid of the 2x. I'm going to subtract 2x, copy, paste. Since these are unlike terms, I'm going to paste off to the side. If I haven't used it, I drag it down. So we get y equals 9 minus 2x. I said no, I'm going to stop, chop, chop here. And there's my new equation. We have y equals 9 plus negative 2x. I did solve for y, so I'm ready to roll. As I put it into the second spot, keep in mind what we just did. We took this equation, we rewrote it in terms of y equals. I'm going to flip these two terms around using the commutative property. Remember, there's a negative attached there. Negative 2x plus 9. So it's in the proper form of y equals mx plus b. Now what we're working for is a solution, or when is there an intersection? When is there a match? So I'm going to start with the table. I'm going to pick the 5 data points that we've been using all along. So we have y equals 3x minus 1, and we have y equals negative 2x plus 9. I'm getting that as I rewrote those both in the form of y equals. One was ready to go, the other was not. Substitution of the x values would be negative 2, negative 1, 0, 1, and 2 for both. Go ahead and get those substitution of the x values in. We're going to look for the intersection where there's an x, y that's exactly the same in the table on the left as well as the table on the right. Plugging in then, so I'm going to take this negative 2 and I'm going to plug it into the equation. So that becomes 3 times negative 2 minus 1. So 3 multiplied by negative 2 minus 1. You can use your calculator on that if you need help. So 3 times negative 2 is negative 6. Minus 1 is negative 7. So we have a negative 7 there. We're going to substitute the next value, and we're going to take the negative 1, plug it in. So we have 3 times negative 1 is negative 3 minus 1. Output is negative 4. Again, if you need your calculator, go ahead and pick it up. Plugging in a 0 now, so I take the 0 and I plug it in for x. 3 times 0 is 0, minus 1 is negative 1. I'm going to plug a 1 now in, so that's 3 times 1 minus 1. 3 times 1 is 3, minus 1 is 2. I'm going to plug a 2 in now, so we have 3 times 2 minus 1. 3 times 2 is 6, minus 1 is 5. So I'm going to go with those 5 as my inputs, see if I get a match here in this next table. In this next table, same idea. I'm going to show my work over in this space as you start to see me, but I'll have to erase it. Negative 2 multiplied by negative 2 plus 9. I have the beauty of doing that on the smartboard. That's positive 4 plus 9 is 13. That one's not going to fit on the graph. You feel free to use that calculator, guys. Here we go. Plug in negative 1. We have negative 2 multiplied by negative 1 plus 9. Negative 2 multiplied by negative 1 is positive 2 plus 9 is 11. Plug in 0. Negative 2 times 0 plus 9. That's 0 plus 9 is 9. Plug in 1. Negative 2 multiplied 1 plus 9. Again, pick up that calculator if you need to. You can see a pattern there. Negative 2 multiplied by 1 is negative 2 plus 9 is 7. Plug in 2. Negative 2 times 2 plus 9 is 5. So there's our situation there. We are looking for an intersection. The intersection is 2, 5. 2, 5 is the answer because it works for both of the equations, the equation on the left and the equation on the right. So we think our solution is going to be 2, 5. I'm not going to put it in yet. I'll write it down here as I think that that's what it is. We'll wait to confirm. All right. So having said that, let's go ahead and solve the equations to see if we agree. My 2 equations are listed above. I have equation 1 here in yellow, and I have equation 2 here in green. I want to know when are the equations equal to each other. Looking for the intersection. So equation 1 is going to be this one, and equation 2 is going to be that one. So I really want to know when does y1 equation equal y2 equation. So if you remember back to this unit, what we would do is we would drop the y values out and just take the output of 3x minus 1. That is the y1 equation on the left. On the right-hand side, again, we drop out the y value and we substitute this in for our y2. All right, so what we have now is called a multi-step equation with variables on both sides. I'm going to go ahead and stop, chop this so I don't mess any signs up. I take the smallest variable term and I move it. The smallest variable term right now is negative 2x. The opposite of negative 2x is add 2x, copy, paste. Working left to right then, as I work from left to right, I get 5x plus negative 1 equals, and if I haven't used it, I drag it down, equals 9. Hand method kicks in. I'm going to take my hand, cover all of that. I'm going to add 1, copy, paste. If I haven't used it, I drag it down. and I have 10 on the right. So I have 5. X equals 10. Divide by 5, copy, paste. So my x value is equal to 2. I'm pretty sure that the x value is equal to 2. So that confirms it. Looking for the y value now, I can use one of two equations. I can use equation number 1, which was this, or I can use equation number 2. I'll write it over here, but I'll have to erase it, which is this. Looking for my y value. Doesn't matter. I'm going to grab that x value. The x value is 2. I substitute in right here. Looking for the y value. 3 multiplied by 2 minus 1 is 6 minus 1. Therefore, my y value is equal to 5. Going back up to this solution up here. So my solution up here, that my y value is equal to 5, which is what I thought in the table. This is my table answer. This is my equation answer. Now I can confirm that in the other equation as well. You don't have to do that every single time, but when you're taking a test, you really want to confirm that the answer is correct. Negative 2 multiplied by 2 plus 9. We want to make sure that this does equal 5 as well. So as I start to solve, that's a triangle problem. And we end up with that the y value then is equal to 5, and that does confirm it. So we have to do table, which we've done. We got an intersection or a solution. The answer is 2, 5. In our equation, we got an answer of 2, 5. All I'm doing right here is checking to make sure that that's correct. That's all I'm doing there. No additional work, just making sure that that x is 2 and the y is 5. So the last piece is the graph. The graph should have an intersection. The two lines should intersect at 2, 5 if all of my work has been correct. You can either fast graph this or you can plot the points. I'll go ahead and plot the points. Elevator analogy, I have an elevator at negative 2, so where I am at right now is I will highlight in blue, negative 2, negative 7. So I start at the front door of the hotel. I'm going to go left 2 to find the elevator and down 7. 1, 2, 3, 4, 5, 6, 7. Elevator analogy over here, I have negative 1, negative 4. Left 1, down 1, 2, 3, 4. Elevator analogy there, not left or right at all, just down 1. Elevator analogy, right 1 up 2. Elevator analogy, right 2 up 5. And there is my straight line. There it is. So that's my first equation. That would be the equation y equals 3x minus 1. I'm looking for the intersection. It should be at 2, 5. Once I graph them, I'm just going to confirm that that's correct. So as I start to graph, I'm going to graph the other equation over here. Elevator analogy, so I'm going to go ahead and highlight in purple which problem I'm doing. I'm going to go ahead and start graphing this entire set. Negative 213 is not going to fit on the graph. So I'm going to go to the next one. Negative 111 is not going to fit on either. So here will be my first data point, 0, 9. So as I plot 0, 9, then I want to make sure that I get something on the graph here. So I look for an intersection, 0, 9. No left or right movement up at all, just up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 on that y-intercept is 9. 1, 7, right 1, up 1, 2, 3, 4, 5, 6, 7. 2, 5, right 2, up 1, 2, 3, 4, 5, and there it is. There's that intersection which we were hoping for would happen of 2, 5. We see it in the table. We got to confirm it in the graph. So we have this giant intersection right here. It's called a POI in math, and it's at 2, 5, known as a POI. So we have a match. So this would be the graph. So we have it in the table, we have it in an equation, and we have it in the graph. Table, equation, graph, all of them have the same POI. Every single one did. Okay? So guys, that's what we're working on. It's just a review of table, graph, equation, system of linear equations. You have to have an intersection point, an x and y that works for both equations. That's going to be what you're reviewing for tonight's work. For summaries, remember you do have to write the equations in y equals mx plus b form, which is the same thing that we've talked about is called solve for y. You're really good at it. It's the hand method. Just make sure that you solved them all for y before you graph, before you table it, and so on. Then, after you do that, remember that a solution always is an ordered pair. It has to be two things. Some of us forget. Some of us just solve for x and then we stop. You have to plug back in to get the y value. So make sure your answer is always an x comma y pair. Be very careful about that or you only get half the credit or possibly you won't get any credit at all. And make sure you check into the original equations. You really should check for both, especially if it's an assessment situation before you turn a test in. That confirms that all of your work is correct. you really should check for both. So that is our classwork for today. Great job on our work today. We're at the 15-minute mark, which gives you some time to do homework. Your homework then is to do page 2 and page 3 due tomorrow. Have a fabulous night, 8th grade.